Cool. All right, now we just wait. Let me edit the privacy. Okay. There we go. That looks pretty good. And now we wait. Hello, hello. There we go. A little surprise stream today. Oh, I should probably pick up that chat, huh? So I can actually read. Here we go. Just gonna drag this guy over here. Hello, hello. Hello from Germany. Someone came prepared. How would you calculate the mass of a black hole? Hello, hello. Just wanted to do a, I don't know, like an hour-long live stream, get back in the swing of things. I posted in my community tab about what question people tend to not like answering when asked directly, whether it be like what a dipole is, or a moment, spin, tensors, and y'all had a lot of comments, so I thought it could be fun to just go through these. The purpose of the videos when I used to do that, reading comments, was to make it more interactive in the first place. So I figured, why don't I just make it a live stream and go through some comments that were already posted and go through yours as well. Sound good? Coo. Tensors are confusing. Is physics better than computer science? How much algebraic geometry do you need to learn for string theory research? I'm not a string theorist, so I don't know. Here, let's go ahead. I'll probably repeat myself a couple times. First of all, how does all this sound so far? The audio sound okay? It's not like too loud, too soft, too much feedback? There's a cat right here, though, if you haven't noticed. Sounds good? Awesome. Finally. Right on. Cool. Yeah, so which question did you secretly hope no one asks you between a moment, spin, and tensors? These were the ones, the big ones, that when I was in undergrad, I was never prepared to answer. For different reasons, too. And I guess I wasn't really too alone, especially with the moment one. I figured that one would be one that people had to let the smallest amount of intuition over. I'm actually making a video on that, so I'm not going to talk about how I think about moments here, because I don't want to take away from that. My nose is stuffed up. Yeah, it is. Some background noise. Oh, I might have had the audio turned up too much. It might sound a little bit different now. I guess one thing that this is going to be tricky with is I won't know if these are questions for me or just questions that people don't like asking. Because I'm just interested in what else everyone else doesn't like being asked. So let's just start reading through these comments. I'm going to keep this up just because I'll probably post the live stream afterwards. What's the best way to do this? There we go. Good enough. Okay, let me read through some of these live chats first. Actually, tensor is really, what was it? Easy to explain if you know endomorphism. All right, yeah, let's just start going through these already live, or these posted comments. So out of 7,000 votes, almost half of people who voted said that moments were the most confusing. That's good, because I'm making a video on moments, how I think about them. Spin, I don't understand enough to make a video on yet. I feel like every time I learn more about spin, I learn that there's a new layer to spin that I need to understand that I just don't. Like when I started taking quantum field theory, and then you see spin as like this consequence of special relativity, like the group associated with special relativity, how you can decompose it into like identical copies of SU2, which has to do with spin that you'll learn about in quantum mechanics, and you're like, why the hell is this showing up? Apparently spin has to do with special relativity now. So like every time I think I understand spin, something happens where no, I don't. Tensors I feel good about though too. Okay, so first one, Zilliwonka. So I was the only bio major in my differential equations class. I was taking it because I just genuinely enjoyed math and was curious. Everyone else in the class was an engineering student. My professor used an example involving a moment for a problem, and I had to ask what exactly is a moment. Long story short, multiple people in the class tried to varying degrees of success to explain it to me. That sounds all too familiar. I see him. Am I missing some comments here? Anyways, I think what that is when moments are introduced to physics students, you end up seeing them a lot of different types of moments. And because of the repeated exposure, it kind of tricks you into thinking, well, if I've seen it this many times, maybe I understand it. I don't know if it's an ego thing where you like, you see it so many times to where you don't even think if you understand it. You just assume that you do, and then someone asks you about it, and you assume you have an answer. So you just start rattling off about, oh, it's a distance times a thing, and you pretend that's helpful. So I don't doubt that happened, that a lot of people went into an explanation expecting more from their own explanation than probably what they gave you. I'm in solid state physics right now, and I honestly don't ever want to be asked to draw a 3D lattice. My notes have recently been populated with attempts at copying how the Fermi surface of different atoms intersects the first... I don't even know what I'm reading. Copying how the Fermi surface of different atoms intersects the first Brazilian zone, and it looks like I'm trying to summon something unwholesome. I don't know the first thing about solid state physics. Let's see, maybe other people are... That's what I like about live streams, is there's always someone who knows something that I don't. You know? Like this stuff I know nothing about. I mean, of course I know a thing or two about Fermi statistics. I like to think so, but I don't know much about solid state proper. Ha ha ha, cat. She's meow meow. I like how people know the cat's nickname. That's funny. Door hinges! Yes, finally, someone understands moments. What are you going to research in? That's a terrifying question, especially when you're an undergrad going into grad school and people don't understand that you don't really know yet. Best way to answer moments in torque physics exams. Have you started your PhD? I'm going to assume... Let's see. This is going to get confusing for me for if questions are for me or if these are just questions that you don't like being asked. So I'll try to guess based off the context. Dito, I've seen your name a bunch of times in comments. You always have something intelligent to say. Spin space is a representation of the SU2 by SU2 Lie algebra, which is isomorphic to the Lie algebra of the Lorentz group SO13, in case anyone wanted to know what Andrew's talking about. That is exactly what I'm talking about. Yeah, you decompose SO13 into two kind of identical copies of a smaller group that is irreducible, and we know how to express different representations of SU2 using ladder operators. That's what you do when writing out these Clebsch-Gordon coefficients and the addition of angular momentum. So you end up being able to write out all possible representations of the Lorentz group in terms of SU2, in terms of ladder operators, basically. So you can write out any possible spin particle that would be consistent within the framework of special relativity. And when I saw that, I was like, holy shit, that's really cool. That being said, I still don't understand why that happens. I don't even know. That's not really a well-posed question in the first place, but one day I'll understand that better, hopefully. If you're new to my live streams, which I don't do too frequently, I tend to get derailed from my own conversations and go off on tangents telling stories sort of related to what a question I just read was about. And yeah, that's just what I do. So I'm sorry if people want me to stay true to the topic a little bit more. I'm not going to be staying on the topic of these questions the entire time. I'm going to get off topic a bunch. Why aren't you finished yet with your bachelor's degree is a question I seek to avoid. That sounds like a question that's not fun to answer if you've changed your major one or more times. Because if you're like me and you started out as a... Well, it doesn't matter if you started out as a bio student like I did. But I was a bio student for like 2 years until I came to my senses. It's a joke, by the way. But still, that's 2 years. Probably 1 year of that was roughly gen ed, so it does tack on an extra year, and that's embarrassing to admit. That you were more sure of what you were going to do with your life than you should have been. I think that's the embarrassing part, is like you convinced yourself you knew what you were going to do, and then you changed your mind and you have to talk to those same people that you were like, this is my plan. Airsofter. Yeah, I went through a couple of these already, either through notifications or just day of release of this post in the community tab. I always love an Airsofter post because it's always something smart. I know things are going to go badly when I'm asked about calculating the symmetry factor of Feynman diagrams. I swear it's always skipped over in lectures as, oh, now we can just get this last factor by some basic combinatorics. No, it's a lie. It's so fiddly and easy to make a mistake. I could not agree more. And my comment was like just basically talking about how long it's taken me to just figure out how to systematically figure out the combinatorics for Feynman diagrams. Does anyone give a shit about that right now? I could talk about what I'm talking about. Let me read through some of these live comments. What's the point of a live stream if I'm not reading the live comments? Worst question, how to pronounce... Okay, never mind. I also started as a bio major, then switched to physics, so it took me 5 years. Took me 5 years as well. Fractons? What the hell is a fracton? How to become great at solving undergraduate physics problems as exercises. Something, it's hilarious. There were certain topics going through undergrad where I didn't give a shit about what I was learning. It didn't sound that interesting to me. It was harder than it was insightful, whatever reason it was that I would come up with to like not invest time into understanding some basic physics. But it feels like now the best feeling I have in physics is when I finally feel like I understand something basic. Like, for example, I've been scripting this video of how I think about moments in physics, and it's like making videos on this basic stuff that people tend to have some issues with, even though you see it a bunch of times in undergrad. That's like the best feeling once you finally get a grasp over that. And I was thinking about why is it that moments are so hard for people? What is it about them? And I think it has to do with everyone's favorite book. It partly has to do with everyone's favorite book, Griffith's E&M. Hands down, in my opinion, the best resource for undergraduate level E&M. You probably already know that if you're a physics student. If you don't, you will. It's this little blue book right now. Does an awesome job going over and motivating the multipole expansion. So like approximating how a potential due to a charge distribution looks at from various distances from that distribution. That's the point of the multipole expansion, and Griffiths does a great job going over that. However, I don't think he did the best job explaining the terms in the multipole expansion itself, like developing a sense of intuition for what a dipole moment represents, or what a quadrupole moment represents, or these higher order moments. And I feel like if you take an introductory class that early, like E&M, and no one says, hey, that's important, then maybe you know where the multipole expansion comes from, but you have no idea what the terms that make it up mean. And then you talk about something like a moment of inertia, which is like something that's weighted by a different power of distance, and then you're like, okay, I definitely don't know what a moment is. So I can see how it can become this convoluted concept, even though you encounter it so many times. Is 25 too old to pursue a career in theoretical physics? Absolutely not. I go to conferences and I see people who are where I'm at, but plus 20 years. You know, it doesn't matter. No one gives a shit. And in fact, the older folks who you'll see at these conferences, I don't know. I feel like they tend to think different. They're more interested in understanding for the sake of understanding. I don't know. It's a more usually a more mature mind, a more honest mind as well about what you know and what you don't know. No, it's not a bad thing to get started later. Not that it matters if I were to have said the opposite, you shouldn't take what I say. It doesn't matter what I think anyways. But hi Andrew, you still learning string theory? Why did you stop the live streams? I've taken a break from the live streams. That will be the next one, only because. So I've taken a break from them only because I noticed that if I go, say, a month without doing one, I find myself just catching up on what I had learned last time. So I'm not really moving the needle forward. I'm like moving it forward and then it resets. And so in my mind, I'm having kind of a hard time understanding this remnant gauge symmetry that Tong's notes have been saying. Like, we haven't used up all of our gauge symmetry. And I haven't gone back to understand exactly how he's quantifying how much gauge symmetry you have in the first place when he's going through like this. The concept of a pullback metric is also not the most. I'm not that comfortable with it. So when he goes to that and then starts talking about remnant gauge symmetry and reparameterization invariance, I don't know. I don't really understand. I need to connect the dots to myself, but I don't want to waste time in a live stream doing that. So I guess to answer your question, it's just been laziness on my part. I haven't done that, which is what I need to do in order to get to the next part in the live stream. Let's read some more of these. Can you give me some advice? I'm an undergrad engineering student who loves mathematics and enjoys reading physics textbooks. I can't give advice unless it's like a specific question, I don't think. I have a genuine, maybe this is your follow-up. I have a genuine passion for the physics as it gives me an edge to understand the topics. Yeah, I mean, if you have advice, like you have tips that you don't know how to take the next step, maybe I can work with that. But if you're telling me, I love that you love physics or in engineering, but I don't know what tips to give based off of the information you've given me. I think the advice always depends on the individual, I think. Can you explain what a job that isn't a researcher or a teacher in theoretical physics is like? What do people working that job usually do? I mean, to me, that's kind of, I don't know, I think that's kind of like asking, what is a job like in real estate if you go into selling Dunder Mifflin paper products? Like, it's not the job that you got your experience in, like your professional formal education in. It's a different thing. In my opinion, if you're not using theoretical physics to research theoretical physics, then you're just doing a different job. And that's fine. People have changes of heart. And that can come from like what you were hoping to get out of the job not aligning with reality. So the motivation for leaving it, sure, tons of different reasons for doing that. But if you're doing, why would you want to do theoretical physics to not do theoretical physics? Or in any case, why would you generalize that to any degree? Why would you spend the time and money doing a degree that you have no plan or intention of doing professionally? Things are allowed to be hobbies, and you can find information on your hobby for free, assuming you already have internet, I suppose. So if you're not going to do theoretical physics, do the degree that's going to help you with your real career path. I don't know. That's my 2 cents. I think too many people treat undergrad as like this experience for everything but getting a professional formal education and the thing that's going to help you with your career. Which, by the way, is how I treated it early in my undergrad as well. So I'm seeing something from myself, I guess. Okay, let's get back to reading these actual comments that were staying on topic. So the topic is, what questions do physics students hate being asked? A tensor. Oh, so this is just an explanation for one of the tensor ones. The ones that everyone has heard. A tensor is an object that transforms as a tensor. If you give this explanation to someone who doesn't know what a tensor is, I think you already know what the outcome is going to be. It's almost just like buying yourself more time, because you know that explanation is useless to someone who doesn't have any intuition for tensors. This is actually hilarious. The moment one. It is funny to see that the things that I struggled with undergrad moments span tensors seem to be about what most other people, at least one or another, is what people struggle with. Funnily enough, a moment is actually a pretty simple concept when viewed in a pure math sense. The nth moment of a function f of x is just the integral of f of x times x to the n. I don't know if that's a concept, though. That's just a definition of a moment. It's kind of semantics there, maybe. I don't know. I think maybe it has to do with when someone asks you, like, what exactly is something, I don't think they mean it. I kind of agree with Captain Snake here, where if someone asks me for a definition of something, I have learned to give a mathematical definition. It's something that everyone agrees on. There's hopefully no ambiguity in it, and it doesn't matter. It's not subject to like my possibly limited interpretations. But I do think when people ask what exactly is spin or what exactly is a moment, they don't mean give me a mathematical definition. What they mean is I'd like to develop some intuition for this thing. What's your go-to example that we can extract general physics properties from, and I can immediately apply that to other examples? That's what I think they're looking for. That's very different from a general definition if I just write down a mathematical definition. So part of it is just like, I guess it comes down to there's always a difference between what was said, what was heard, and what was meant. So as long as like you understand I may not interpret your question the right way immediately, and your question may hit my ears the wrong way, and it may take a couple iterations to really get to your question. And I guess in other words, don't ask a question that you don't have the time to hear like a thoughtful answer for. It's my take. The tensor question is hard for this person. So many different definitions that are kind of related, but not exactly the same. That might be what some people would consider a benefit. You know, like if one way of thinking about something isn't working for you and I give you a different way of thinking about it, is that a bad thing? Something that's related but seemingly different. I don't know. With tensors, really, I think it just has to do with... Whoops. Sorry, if RuneScape is about to pop up on accident. With tensors, physics is like all about kind of predicting what happens next. If I know the initial conditions of the ball that's being thrown, can I predict where it's going to be later? And that's like how, I guess, physics is changing, which is a real concept. However, you can have two different people describing the same physics, describing the same ball going through the air in different ways. Because I can choose a coordinate system, and you can choose a different coordinate system. And though mine is obviously better than yours, just kidding, the fact is if we're using two different descriptions to describe the same physics, there must be a relationship between your description and mine. And the beauty of tensors is that we already know what that relationship is, if it is a tensor. That's it. It's not a matter of... It's a way of connecting the dots between different descriptions of the same physics. If I don't know how two different descriptions are related, is that really useful? Usually not, which is why physics has more utility if it can be written in the language of tensors, in my opinion. Okay, back to the live comments. I also like that I can read your takes on this stuff. So let's see. A tensor is something that has to be described differently from different perspectives. It's kind of hitting on what I was saying. Yeah, absolutely. The thing about definitions is that they lead to more definitions to be understood, which totally turns off a layperson. What happens when you heat up a gas and look at intensities of the spectral lines? This is just a regular question. Leave that to you guys. Spin is an intrinsic angular momentum like charge or mass that contributes to angular momentum conservation. It's an internal degree of freedom. Two good explanations for spin I've heard. My favorite one is it's the total angular momentum of a particle at rest. Uh, isn't a tensor just linear algebra on steroids? Not necessarily, because I mean, if you have in linear algebra, you have a vector that's being acted on by a matrix, and it spits out another vector. A tensor is more general than that, but in order to appreciate the generality, you'd have to understand the difference between covariant and contravariant indices, because a general tensor doesn't just have to act on a vector and spit out a vector. It could act on a vector and spit out a covariant vector, or so it could spit out a vector that lives in a different vector space. It's not, I don't know. People will refer to tensors as multilinear maps, but I don't know if they're just referring to mixed tensors when they say that. What is this? I saw not a question I hate. Did I skip it? Did I just miss it? Weird question, are there any applications of rank 4 plus tensors? I think there's a rank 4 tensor in, like, geophysics, if I'm not mistaken. I forget what it's called, but I know some I'm pretty sure it's like some tensor product of two second rank tensors. Fourth rank tensor, the Riemann curvature tensor as well would be a fourth rank. I don't know if I know of any others. I guess there's the totally antisymmetric Levi-Civita tensor as well. It's got 4 indices. Those are just a couple that come to mind. If everything is at rest, does it mean nothing is? I don't know if this has to do with my comment about spin being the total angular momentum of a particle at rest. If you have one particle, there's always a frame of reference where that particle is at rest, at least instantaneously. So if you can instantaneously go to the rest frame, so if you ask the particle how much energy it has, the particle is always in its own rest frame. It's never moving relative to itself. That's why a particle of a certain mass won't decay into something heavier just because in a different reference frame it had kinetic energy as well. It just has its own mass energy to work with. That's what the particle would know. And in the same sense, in its own rest frame, if you were to ask what its angular momentum was, it would answer its spin, not additionally some contribution from orbital angular momentum. So I'm not saying there's a reference frame where everything is at rest, but there could be instantaneous reference frames for any individual system, or at least where the center of mass is not moving. Of course, if there's accelerations, then you have to have instantaneous rest frames, because there's no Lorentz transformation that will put you in an accelerating reference frame. What branch of math do you think is the most important in physics? Which ones are worth studying to get deeper understanding? If you're doing your physics degree, they're gonna tell you what you got to take. But I guess that's not fair for those of you who just want to learn independently. So I'd say you start with calculus. If you learn your integral and differential calculus, which is usually your Calc 1 and Calc 2, which probably introduces you as well to series, like infinite series, then you can do differential equations or multivariable calculus. I don't think it matters too much which one of those you take first. Linear algebra is always helpful. I don't think maybe you don't need an entire course in it. Complex variables, like I took partial differential equations in undergrad, and if I could go back, I would have swapped that for complex analysis. It comes up way more than neat little ways of solving partial differential equations. Okay, let's get back to the other questions. Let's see. My biggest fear is being asked about different types of moments, especially in E&M. Okay. Glad I'm making the right video then. What can you do with that? That can be a frustrating question because you have to prepare an answer for different levels. Like the answer that you give someone in your field is a different answer for another grad student, which is a different answer for an undergrad, and so on. So it's like, how many layers do you want to have for your explanation? I hope people keep asking me questions, any question. That way I can find out whether I really understand something or not. So that sounds like someone who doesn't have a huge ego, because I feel like as soon as you associate yourself with someone who knows this thing, and then someone starts challenging it, like asking a follow-up question, and then you get a little defensive, and maybe blame them for not understanding your explanation. Yeah, this person seems to get it, though. Explain where the assumptions of the microcanonical ensemble come from. Assumptions of the microcanonical ensemble. I mean, the only assumptions I can think of initially are that all microstates are weighted equally, right? Like the probability of any specific microstate is equal. But if the physics tells you otherwise, you would work in a different ensemble theory. You can work with different density of states if you like. I don't know if that's what they're referring to. I guess read more, right? Let's bring this back up. It has been a while since I've had StatMech, though, so I could be forgetting something. In StatMech, we just postulate it. Do we expect this postulate to be fundamental? Does anyone know what postulate they're referring to? Am I just being dumb? What else could it be? Assumptions of a microcanonical ensemble. So I guess, yeah, what other assumptions are we making? We cycle through all microstates in a way that the time average is the ensemble average. Ah. So you're asking, why do we, are they asking why we assume time average statistical mechanics gives you the same result as ensemble average StatMech? I don't know if I've ever thought about it in depth. I mean, if you switch to say, like, if I wanted to understand how the evolution of a person over time, like a person's aging, I could wait. If I have 80 years to wait and observe a person, I can get a pretty good idea of how people age. Or I can take a snapshot of thousands of people at random points in their life and try to assemble the timeline from there. So one requires a large sample size of people, and one requires one person but plenty of time on my hands. I don't know, it sounds fine, but I've never tried to prove it. Apparently half of this chat wants to do mathematical physics. Maybe I just attracted a specific kind of person. Do you ever feel like you're not good enough for physics and wanted to quit? I mean, my first year of grad school, my first semester, I wasn't even part of the program. Like, I was non-degree seeking because I wasn't accepted into the graduate program. So, like, I totally understand imposter syndrome. Once you start to get a feel for how much the people around you, or how, I guess, no one wants to feel dumb. And so what you're seeing from other people is a very filtered view. You're seeing what they want you to see, and you should always remember that. Like, very few people are willing to put their ignorance on display. So just because you don't see people asking a bunch of questions, to me, I'm like, that means by the end of this, they still have that question. And if I just ask my stupid question, it may be a stupid question, but I won't have it anymore. So, like, if you feel like you don't know enough, ask more questions. Okay, back to the regular comments. What else do people not like being asked? Oh, so you want to do particle physics? What are you going to do with that? That is I have a hard time talking about immediate applications of my own research. I think that's something that I struggle and get a little, not, I don't know if it's defensive. Maybe it's defensive. But if I'm asked it and I don't feel people get the impression that it's worth funding or don't understand the concept of why certain things require government funding and it wouldn't make sense for it to be privatized, yeah, that's something that I still have to work on for sure. More stuff on moments. What's the difference between quantum physics and quantum mechanics? There is no difference. Quantum physics, quantum mechanics, quantum theory, they're all the same thing. It all just depends on... I feel like I've heard people in physics refer to it as quantum mechanics more, and I've heard more people who are trying to impress you call it quantum physics. That being said, there are also undergraduate or graduate level textbooks that are called like quantum physics, like by Gasorowitz and things. So who cares? They're the same thing. Someone says, discoveries are the application. You don't need to justify why you're researching particle physics to people who run around for paper. I don't know. I don't know if I agree with that. I think there's a limited amount of funding. And if you're to suggest that yours is worth it, you gotta do better than, here's this thing I'm interested in, and I have no idea what it could possibly be used for, or if we're going to find it. It's just, I understand that fundamental research is fun, exciting, and we think it's important, but it means nothing if you can't convince people outside of it. I'm 18, currently confused about choosing physics and engineering, getting more inclined towards physics, but my parents suggested me to take up engineering because it's demanding. Engineering versus physics. Well, I got news for you. The first couple of classes you take are going to be the same classes, regardless of if you're a physics student or an engineering student. No one makes you pick up or make up your mind immediately from getting into undergrad. So if you're not a degree, if you have no degree plan immediately, that's fine. If you just know you want to do one or the other, then you have time to figure it out by taking the regular intro classes that anyone is going to have to take. And then you'll also have additional resources and opportunities to speak with professors in the field to see like what topics are actually out there. It can be hard to know what you want to do professionally when you have very limited experience. So just talking with as many people as you can in the department is how you can start to narrow that down initially. So if you spend some time in an engineering department because you have to take some gen ed for that, or if you have to take general physics, I wouldn't blame you for not being incredibly interested in friction and air resistance, but use it as an opportunity to explore the setting that you're in at the department itself and talk to the people there. Because you're not going to be able to put the picture together by yourself if you're just starting out. Someone says, I did my undergrad in engineering and switched to theoretical physics in grad school. So that's possible as well. Yeah, I mean, you'll see people with astronomy backgrounds going into physics, vice versa. As long as I think you've demonstrated to whatever graduate committee is in charge of saying yay or nay to who enters their program, as long as you've demonstrated that you have put in the time to convince yourself that you like doing research, I think that's probably most important. And what your research was in comes second. So this person says, a differential cross-section in particle physics. What time is it, by the way? I don't have too much time. 12:47. So I've got like 20 more minutes, and then I'll have to close out the stream. Let's see. I'll read a couple more. How about this? I'll read a couple more of the posted comments and then I'll turn my attention just to the live chat because, like I said, what's the point of doing a live stream if we're not talking to each other? How do you calculate the angular momentum of an electron? Easy. You take a quantum mechanics course. What exactly do I think about my job prospects? Now that's a question that requires that you are an honest person to yourself. Oh yeah, I read this comment. This one is so funny. A moment is a magnitude that is conserved if the conditions for moment conservation are satisfied. Spin is like a ball spinning, except it's not a ball and it's not spinning and it has no classical analogy. And a tensor is something that behaves like a tensor. Easy, next. That reminds me, I saw one meme that was like referring to defining anything. Say like, I don't know, a microphone is something that transforms as a microphone. Why is the flux integral 0 in your calculations? Where there is symmetry. If that happens, I'm looking for a symmetry. Where is the symmetry? Duncan always has something smart to say. Explain the tensor product of vector spaces without universal properties. Explain the tensor product of vector spaces without, universal properties. I don't know. So, Duncan, I don't know if you're referring to global or local properties of tensors, or if that's even a question that makes sense. Not that I'm not saying your question doesn't make sense, but me translating your question into one that I can understand. Let's just read more of what he says. Tensors I'm fine with. I farm points on physics stack exchange by explaining real mathematical definition of tensors instead of the more general physics one. I don't know what you mean by the more general physics one. Spin is natural once you realize particles as unitary representations of the Poincare group. Okay, so again, I guess a lot more people understand this than I gave people credit for. I just didn't understand this concept until like the last 2 years or so. Spin and this consequence of special relativity. The nth moment of a quantity. Again, I think that this is a definition. I don't think that explains anything. I don't mean to be anti-semantic there, but tensor products only make sense in differential geometry where the vector space with bases as the real number product of the output of pairs. I'm going to need to read that again 4 times after this stream. I'm not going to pretend to read that at one time and get it. Airsofter's there. Here we go. I don't know if you saw my message when I was here at the start. I did not. Meant no disrespect. But if you want some... Wait, shit. But if you want some more info about the stuff in Tonk's notes, feel free to call. Absolutely, I'll shoot you an email. I think I have your email. He's like our savior to hold my hand through this stuff. I want to build a bunch of. Okay, I'm gonna just stop reading the regular, the comments about what students don't like being asked and just turn to the live chat from now. How about that? What do I leave in the background while I read these, though? Let's see. Here we go. Let's just put this up. Yeah, let's do this. Always have OneNote open. Oh, someone said, Aiden Clark, I just had a talk from Professor Briseno about the program at ODU. Very excited to be part of the department. Dr. Briseno is such a nice person. Where is he? Where did that comment go? I want to read it. I have nothing but nice things to say about him. I missed it. Where did it go? Am I too far down? Go back up. Okay, I don't want to go too far up. Pop vibration is something I've only heard of from Eric Weinstein. I don't know anything about it really. Yes, anti-semantic. Meaning I don't want to just disagree with someone because of how we're defining our terms. If we know what we're talking about, but we've accidentally given two different definitions to the word, I don't want to, it's not really worth arguing about if we don't actually disagree. Do you think it's possible to get more people into physics and science in general? Is it a science communication issue, or are people not fundamentally inclined towards these subjects? I think it has to do with just being creative. I think it's always, when in doubt, blame the person communicating it. It's kind of their job to know their room, to know their audience, and to try to put themselves in other people's shoes. That being said, I am not the biggest fan of this idea that physics should be dumbed down beyond any hope of applying it to people. Like, at a certain point, it's like, should we start training our intuition a little bit more? Like, maybe everyone has some idea of what algebra is. As we get more advanced, should we get more intuition for more advanced math? I don't see why not. I mean, if physics keeps getting more and more involved, but common intuition doesn't, then we're just having to dumb down concepts more and more and more. And I don't know. I haven't thought about it too much, but usually it's safe to assume. Usually, I think it's on the communicator, not the person being communicated to. Especially if it's something you're insisting they hear, and not something they're asking you. What is the best book to teach quantum mechanics in the undergraduate level? Which one is worth investing in? That's a question I wish I had a better answer to. The standard that we used when I was an undergraduate quantum was Griffith's Quantum. I still don't know if I like that book. The reason I'm not the biggest fan of it is partly because of how late it introduces Dirac notation, or Dirac's Bracket notation. It's like the most ubiquitous notation in quantum mechanics, unless you're learning from like Weinberg's book, I'm pretty sure. And I refuse to write out basic quantum mechanics calculations in any other notation now, but I feel like it waited so long to introduce it. And I feel like also he could have used what he used in his E&M, which was a big mathematical primer at the beginning, where he went over vector calculus. I feel like there could have been more linear algebra background in that book as well. So I don't have a go-to undergraduate quantum book. I will say my go-to graduate level one, but this is a big jump, would be I don't have it on my shelf right now. It's Sakurai's book is my favorite. Under that would be Shankar's. Okay, I'm currently in my first master's in radiation physics. Have a choice between lasers and nuclear for my second year, and I was wondering, what do you think of them? I think both of those are really big fields. I forget the acronym. It's like atomic, optics, and molecular physics is usually a group that's lumped together, and there will be funding opportunities for like all of that together. I think one example, I hope I'm not speaking wrong, fact check me on this, but I think Stony Brook, I think they have a big AMO department, if I'm not mistaken. So there's tons of prospects if you want to get into lasers and atomic physics, which I assume is what you're referring to. And the nuclear physics, it's probably just the same. It depends on what your particular interests are. I think nuclear physics is probably better than a lot of other fields because you can go DOE funding and NSF, or maybe you can go DOD funding. And yeah, so it really depends on what your interests are, but there are options for both. Physics is, there's a lot of fields of physics that are very competitive, but there's still kind of a lot of opportunities there. Like condensed matter as well, especially condensed matter in solid state with research endeavors and your chance of going into industry. Like if you're just worried about getting a job, it seems, I'm not a condensed matter physicist, but it seems like there's quite a few options there. Okay, finally back to Aiden's comment. I just had a talk from Professor Briseno about the program at ODU, and I'm very excited to be part of the department. What should I expect when moving to the Norfolk area? I guess it depends on if you're staying as, are you going as an undergrad, did you say? If you're an undergrad, I mean, there's tons of like on-campus housing. I lived in Virginia Beach and just commuted, so I don't know too much about Norfolk housing, unfortunately. But yeah, there's a lot of housing options like right off of what is it, Hampton Boulevard or whatever, or I think that's what it's called. But unfortunately, yeah, I never lived in Norfolk. I only lived in Richmond and Virginia Beach, so I can't really speak too much for that. But welcome to that department. I mean, nothing but positive things to say about ODU, as I've said a bunch of times. At what point in your academic career did you realize that a bunch of Stack Exchange answers are just plain wrong or try hard? Maybe I'm not far enough because I get a lot of information from Stack Exchange. You should see how many Stack Exchange tabs I have open right now. It's usually about a 60-40 split between Archive and Stack Exchange on my desktop. How to self-study physics, be a more honest person. Pay attention to when you're wrong and when you don't understand something, and don't try not to. I mean, if you're studying it, understand why you're studying it. Try to find the value in why it's important. If you can't do it, then you're going to have a really hard time getting yourself to when you're not motivated. So how to self-study physics, understand the importance of the topic, look up where it might pop up for some inspiration. And then if it's valuable when you don't feel like it too. Don't skip parts just because you're like, just because you who's learning it has deemed it not important. Like that's probably not up to you yet. So if something seems like a lot of detail for no reason, give it a shot, give it an honest shot, and at least keep tabs of if you really didn't understand it so that you can revisit it. So don't bullshit yourself and say like, I think I basically get that. How's your research going? Did you conquer the D term yet? Oh, don't get me started. On the plus side, speaking with my advisors, they've convinced me that we are so close, that it's just about there. There's something that's not quite working yet. I don't want to get into specifics. For those of you who have no idea what I'm talking about, my research is in nuclear theory. I'm interested in how you can probe information about a particle that has to do with how it interacts gravitationally, how to probe that stuff quantum mechanically. It's not quantum gravity. I'm not a quantum gravity person, but the fundamental object of interest is the energy momentum tensor, which is defined from GR. So we treat it as such. But we treat gravity classically, and this D term has to do with, we think, how pressure is distributed inside of the proton or neutron. So we think it's linked to stability of matter, and we're just going through some model calculations of that to get some intuition for it. And it's 50 pages of a calculation. What can I say? Are you familiar with the... Oh, I think I already talked about that. No, I don't know anything about Hop vibration. All I know is Eric Weinstein exists. Best OSRS skill. Finally, some good questions here. By the way, my name... I've been playing my Iron Man on old school RuneScape a lot more. Feel free to add me on there. It's just QCD Boy. I think it's one eye. If it's not one eye, it's three eyes. I can't remember. But... Best OSRS skill, I just love bossing. Um, range is pretty OP for bossing for a lot of stuff. If it's a regular skill, rune crafting gets super chill once you can do blood runes. I haven't checked out the Rift Guardian yet, but I heard that kind of changes everything. Slayer's fun once you start actually making money from it on it. I sound like such a dork. Let's see. Hold on. What skills are there? I'm going to pull up my main real quick just because... Oops. Because this is stuff that all of you need to get into if you're not. Because I know for a fact you were happier in 2007, and so why not just start playing old school RuneScape again? That's all I'm saying. Hold on. Come on. Okay, so let's look at what's important. This is my main account, Stan Darsh. I'm kind of flexing right now. I'm a little bit proud of it. What's fun? What's a fun skill? Rune crafting is not that fun. Fishing is fun if you're on a road trip. Thieving is fun if you hate your life. I hate that I'm looking at all of these skills that of a game I've spent so much time playing, and I can't look at a skill that's actually fun to train. Okay, this is getting depressing. Construction's cool, man. You get some nice unlocks as far as like teleports and rejuvenation pools and whatnot. All right, I'm embarrassed I showed you guys that much. I feel kind of dorky. Speaking of Tong's notes, how's string theories prep going? I mentioned this a lot earlier in the stream. What's made it hard for me to keep making streams about it is I keep forgetting what I've learned. And there's like hiccups that from what I've read already that I still don't truly have ironed out, that I want to have ironed out before I do the next stream. So I just need to stop being lazy and understand some stuff I've already read. What's your take on advanced mathematical analysis for physics? I keep hearing people, sometimes I'll have these questions and I don't know. It'll be a mathematical question that'll be met with oh well, we're physicists, we're not mathematicians, and that drives me crazy, man. It just does. I think there's no downside to thinking more like a mathematician. As long as you don't write down the definition as an integral and be like, see, I do understand what this thing is physically. Can you comment on the state of research quality in the physics world? I'm in a PhD program in statistics, and I worry that it's too easy to publish bad results. I guess it depends on the journals that you're trying to publish in. And I know nothing about what journals people publish in for math. I know... I don't know. From my limited experience, your referees can be pretty brutal and not let a lot of shit go by. In fact, there's examples of like the referee making a suggestion that made the paper a famous paper. For example, oh shit, was it Yang? I want to say it was Yang from Yang Mills, who was the referee for a certain particle physics paper, and then in the referee comments was like, "Hey, by the way, you know you just predicted another particle, right?" So like, I appreciate the role of referees. I appreciate that they can be very critical and very brutal. I don't think I would have it any other way, but it seems like you're suggesting it's too easy, so I don't know. Maybe I'm not careful enough to appreciate. Maybe it's not easy, or maybe it is. What am I trying to say? I'm trying to say maybe I'm wrong, and I'm just not a very careful person, and so people are just calling me out on not being careful, and it's totally warranted. But even if people are being careful, yeah, never mind. I'm kind of just rambling. Do you ever think or fret about the pros and cons doing a PhD as opposed to getting a job in industry? I'm going to graduate this summer. I have no idea what to do. Yeah, more and more each day. I mean, I've pretty much decided that I don't, as of right now, I don't want to be a professor, which is kind of disappointing to say, because that's part of what got me into physics. I do still want, I also don't want to be a full time YouTuber. Like, that's not my goal still. Like, I don't intend on getting my PhD and then doing YouTube full time. Um, but as of right now, my path is very much become a full time researcher at some national lab. If that's not what you want to do, if you don't think that'll be happy, which I assume if you're finishing your PhD, you've spent some time in a lab. If you haven't had time, so I guess your research experience in a lab is whatever it is for you. Did you enjoy that? If it wasn't, and you don't want to become a professor, then do you know enough about what research or what industry in that field is going to be like? If not, you gotta talk to people. Your professors may not know because they are in academia, but they probably know people who do, who are in industry, and they could point you in that direction. Don't be afraid to ask questions to people who know more in your department. Fight me in Willy? Nah, dog, I get PK'd by level 3 skillers. I think it just jumped down. Someone said, huh, RuneScape still exists? Yeah, it still gets updated, too. Why does it do that when it just... Someone just commented 50 pages. Yeah, and that's the cooked down version. That's the second draft. Okay, I'm just gonna, I guess, skip farther down because it jumped down for me. What time is it? 1:09. I'll do 10 more minutes of just kind of speed running these comments, and then we'll call it a day because it's probably been over an hour. Okay. Fields have to be either commutative GR or non-commutative quantum mechanics. I mean, at equal times, fields, if you have like a scalar particle at equal times, they commute. If they are like fermions, they obey anti-commutator relations. Let's see. I'll finish Calc 2 and Calc-based physics. Do you think I have a chance of aiding in a lab? So if your physics education begins and ends maybe with high school, are you able... There are programs that are starting that are more geared to people really, really fresh out the gates like you are. I don't know. On one hand, I wouldn't want it to be discouraging. If it's like research, which is at the end of 400 plus years of researching physics and you're jumping to the end of it, I wouldn't want it to be too overwhelming. Like, I don't want you to be in too much of a rush. But on the other hand, there are resources that are starting to give you that experience. Like, I think even Reyes, ODU's Reyes program, again, going back to Raul Briseño and Giovanna Gerard, who were like the main organizers of that program. It's geared to make physics more accessible to people who don't have opportunities, whether that just be your geography, or maybe you're a high school student and want to get a taste into shadowing physicists or something like that. And I think they're starting to do that. So keep an eye on the Reyes program, REYES, associated with ODU. That's the closest suggestion I could give. I guess what I'm getting at is if you're a high school student who's interested in physics, there's physics that's already been figured out that is still going to blow your mind, let alone like just learning about it, just doing experiments people have already done. I don't think you need to jump to the new stuff just yet. But that's maybe I'm wrong. Maybe I'm wrong. Wouldn't be the first time. I've got a bit of free time as my semester break. I know Python. What programming language do you recommend physics students to learn? Oh, okay. If your department has the license that you can get for free, I would recommend messing around with Mathematica. I recommend either learning. I say this like every live stream. I think everyone should learn 2 languages, a real one, and Python. When I say Python, Python is just, it's so user friendly. It's pretty easy to get a feel for, and it's an interpreted language. So I would recommend, in addition to that, also learning a compiled language like C++ or Fortran. Which one you learn, dealer's choice. Learning the syntax of one goes, you can get a lot of mileage for how those kinds of languages work for different kinds of languages. In nuclear physics, there's been so much code already written in Fortran to where it's like, well, I guess I'll learn Fortran, you know. So it depends on the external sources, but I'm glad you know Python, and I would suggest either C++ would be my go-to, or Fortran if you're dealing with 60-plus-year-olds in the field. Okay. Oops. Would you take a greater than 200,000 job over doing a physics PhD? Currently a grad student and not sure if I would go into industry or academia. Would be cool to get your views. So like if someone was like, here's a $200,000 job, but you can't do physics anymore. Yeah, I wouldn't take it. It's just, I mean, everyone has a number. Everyone has that number, no matter how much you pretend that number doesn't exist for you. Make it as obnoxiously large as you want, and then you will say yes. But no, I wouldn't change for that. Considering if you were a top tier physicist and you get a joint appointment at, say, a national lab and a university, 10-year track, this is way down the road though, by the way, that's not unheard of for you to make. That's not the average by any means, but I know physicists, and it's public record, who make that much money. But I do think I could be happy doing physics and making less than that, for sure. Like, half that. Okay. What's the derivative of e to the x? I've been stuck on it for 3 days. With respect to e or x? No, I don't play Valorant. Should I? But it sounds really familiar, but I'm blanking on what that is. Andrew, I hope you're not a Bayesianist. It's kind of a lot of what quantum mechanics is. Which I didn't realize until having a conversation with like Epic Math Time and Flammable Maths, because I was like, I don't really know it, and they were like, yes you do, Andrew. I was like, oh, okay. Physics or mechanical or software startups? Sorry for the duplicate. Do you have the background to join a startup now? I don't know. And is that, I don't know, like it depends so strongly on what would be meaningful to you. What steps you've taken within those fields already. What you'd be happy with financially, what risks you're willing to take. I don't know, it's such a hard question for me to answer. Like what risks you're willing to take is a big thing. Will the standard model be thrown away with the new measurements for the W boson? I know what you're talking about, or I heard about that today, but I haven't read anything about it yet. Here's the thing about a model, is models have parameters that can be tuned. That's why it's called the standard model of particle physics and not the standard theory of particle physics, I think. though you can motivate it and wave your hands and be like, oh, U1 gauge symmetry worked so fantastically well for E&M. Let's play with other gauge symmetries that are renormalizable, and you can say this is sort of a uniqueness thing for the standard model. I think you could at least do that for QCD. But at the end, it's a model, and you can always tune parameters in a model to kind of agree with experiment. Not to say that that's what is always done by any means with the standard model. I mean, if you tune it once, you can't really keep tuning it, right? So how many free parameters are there in the standard model? I don't even know that question off the top of my head. But I don't think anyone... It works very, very well. So a worst case scenario, it's an approximation to something better. So whenever someone suggests like throwing a theory out, that's fine if the theory has always kind of sucked, I think. But like people saying, will GR be thrown out one day? Whatever is better than GR, I have a suspicion GR will just be some low energy approximation to a better theory. But throwing it out, I don't think so. I think you generalize. You generalize the standard model. You don't throw it out. That being said, I know embarrassingly little about the weak interaction. So issues with the weak interaction. I don't know. I don't know what you do there. How do I feel about lecture notes versus textbooks? I don't really have a strong preference. I guess I like having something physical that I can hold on to. Okay, we're about caught up, so I think we'll probably end about right here. The W boson stuff could be really big. A new result, it actually fits really nicely into low energy supersymmetry. However, let's wait and see. I think it's really too early to say anything definite. You heard it here first, folks. Why would we throw away a theory if it's worked for 100 years? I think people are just dramatic, and the amount of emails I'll get that's like, I think we just have to start from the beginning, and these people don't understand how well certain calculations have worked. Oh, thank you for this. Here, I'll get to this comment in just a minute. Like, you take a calculation in QED. Like, QED has given us the most precise, accurate predictions in the history of science. And then you have someone who's really eager, has heard about gravity not being combined with QFT yet in a way that everyone agrees on, and then they say, we need to throw it all away. You don't know what you're talking about yet. I don't know. If you throw something away, if you're going to say we're throwing this away, people will probably hope you have an alternative, or you'll have a damn good explanation of why it's worked so well so far. Andrew, you want to collab? I'm always open to collaborations. I always insist on speaking with and talking with people I collab with first. I don't know. People can tell if you don't know someone that you're doing a collab with, and it just seems artificial. So anyone I collab with, I kind of insist on building kind of a relationship, a professional relationship kind of first, and getting to know you, your sense of humor, these kinds of things. So I'm always open to it, but I would never just, I don't care who it was. I don't care if it was PewDiePie. Like, I'd want to talk to the person first, you know. Okay, let's, 2 more. How about that? How much of QFT does a theoretical nuclear physicist use? Would you recommend doing research if one likes solving problems in QFT? Every day. There we go. There's not a day that goes by that I don't use quantum field theory. I use it every single day, if that answers your question. First, let me go back to that. Here we go. Andrew, just started watching you the summer before I began my physics degree, successfully defend my senior thesis, and will be graduating with highest honors. Much love to you. You're an inspiration. That's awesome. That's so cool. I'm now that I've been making videos for like 5 years or so, I'm seeing people who started around the time that I started making videos who were just getting into physics. Now they're graduating. Now they're starting their PhD programs, and it's really cool to see. Okay, I'm gonna jump down here. How's QCD going for you, Andrew? It's going better. My questions, the things that make no sense. There's no. The number of things I don't understand about QCD hasn't gotten smaller, but they've gotten more detailed. Like now, instead of trying to understand, I don't know, why the gauge fields transform in the adjoint representation of SU3. Instead of like that being the thing I'm grappling with, I'm trying to understand pinched pole singularities. And so, I don't know. It feels like I still don't know anything, but it's like a translational invariance. QCD is translationally invariant to where like you're just shifting your questions, but you're not shifting the number of questions you have. Oh my God, Oxford. Woo! Hell yeah. That's amazing. Okay. Lee, congratulations on that. That's huge. I'm going to end the stream now. I love doing this. To be honest, I made this stream to kind of buy myself more time for the video I'm making on what moments are. So I thought that this would be kind of a fun way of filling that gap, but hopefully I'll have that one done by next week. That's the goal anyways. Yeah, what I guess April's coming up, so a lot of you are probably finishing up or finishing learning or getting your feedback from universities to see if you're been accepted or not. Any other news? Just drop some news for the last couple minutes, I guess. Like one more minute if anyone else has something else that they're super proud of. The nerdy kilt. April's coming up. Thank you. God damn it. Leave my stream. Just goes to show what month it is. It means nothing to me anymore. It's hilarious. Got a PhD in experimental nuclear physics. Inspired me to get it. Wow. Say goodbye to pop music? Okay. What is STEM merch? Is that owned by whom? I should know more about it than I do. I'm not affiliated with STEM merch, but I think that's mostly like Flammable Mats and Zach Starr's thing. Like their STEM merchandise type of thing. It's pretty cool. You should check it out. They've got some cool stuff there. I'm kind of thinking of picking up one of their headphone holder things. Okay. End of the stream. Oh, wait, Aiden had one more thing to say. I'm just interested in playing favorites because I went to ODU. Starting graduate degree at ODU this fall. You were already aware of that from my previous comment. Oh, so you're starting grad school. Awesome. If you're doing nuclear physics, man, there's a lot of really heavy hitters there. There's people at ODU for nuclear physics where their name has been mentioned. And then people I know in the field will be like, when that person talks, you shut up and listen, because they've probably thought about it before. They've thought about it a lot more than you have. So, not you in particular, that's how they said it to me. Okay, anyways, ending the stream now. Thanks everyone for tuning in. I'll probably do another one real soon for the string theory as soon as I iron out some of my own confusion for what I've gone over last time and catch myself back up. But you should expect the video on moments first. Yeah, I'll talk to y'all later. I love you.